So now we'll be looking at the risk equation and why it matters. So the equation is not a math formula you memorize. It is a mental model that tells you where to put controls to reduce the risk. So once you understand it, you will automatically think about whether a proposed control is targeting the right factor. So now I'm trying to break down the equation into three categories. So we are saying we have threat, vulnerability, and the impact. And obviously, it is equal to a risk. So the threat here is the source of potential harm, and think of it as who or what wants to cause a problem. So, for example, a ransomware gang, a disgruntled employee, a power cut, a software bug. So, threats are largely outside your control. You cannot stop a ransomware gang from existing in the world. Now, the vulnerabilities are a weakness in your system or a processes. So, that causes a threat which can exploit. So think of it as a gap that makes a threat dangerous. For example, no multi-factor authentication. We call it as a MFA, which means we are stolen password can get an attacker in. Unpatched software means a non-flow can be used against you, and the vulnerabilities are within your control. So you can close them, and this is where more security investment goes in. So, impact what happens to the business if the threat exploits the vulnerability. So, financial loss, downtime, or it can be a regulatory fine or a newspaper news story. So, which means the reputational can be damaged as well. So, impact is partly in our own control, but if we have a backup which can reduce the impact of ransomware, insurance transfer financial impact, an incident response plan which can have a speed recovery. So these can help us. Now, if any factor is zero, will be risk will be zero. And this is why the equation uses a multiplication here, not addition, which means no threat, risk is zero. No vulnerability, risk is zero. No impact, risk is zero. So a test system with no real data has near zero impact. So even a serious breach of that system is a low risk. So I want to give an example of unlock car. So let's say the threat here is that a car thief exists in your area. Now, what is the vulnerability here? You left the car unlocked with the keys inside. Now, the impact, what can be the impact here will be the car is worth 30,000 of dollar and you need it to get to the work. Now, the risk is high. Now, let's change one factor here. Let's say you move to an area with a zero car theft. Threat will be zero here. Risk will be zero here. Even though the car is still unlocked or you park in the guarded secure garage, vulnerability will be reduced. So risk will drop significantly here. So now we'll be looking at how control act on the risk equation. So every control targets one of the three factors. So if you look at the slide, it shows you exactly how to think about any control you encounter in an audit. So is this control reduce the threat, whether it's closing a vulnerability or limiting the impact? So that question tells you why the control exists and what gap you have if it is missing. So if I'm talking about a reduced threat, firewall rules, a firewall checks traffic trying to enter your network and it blocks non-bad sources. So it reduces the threat by keeping some attackers out before they even try anything. Now, the vendor due diligence, checking a supplier security before you work with them. It reduces the chances of a third party threat entering through that relationship. So, reduce the vulnerability. We have to have a patch management, like regularly installing software update that fix non weaknesses. And unpatched system is non documented vulnerability. Patching closes it. And multi factor authentication, which is MFA, and It is requires second proof for identity beyond just a password. Even if an attacker steals a password, they cannot log in without the second factor. So it closes the weak or stolen password vulnerability here. Now the third one is SOD, which is segregation of duties. So we have to make sure no single person can both authorize and execute a financial transaction. So this closes the one person can commit fraud without detection vulnerabilities. Now reduce the impact, data backups with tested restores. If ransomware encrypts all your file, a good backup means you can recover without paying the ransom. So the attack is still happened, but the impact is reduced from catastrophic to manageable. So encryption at rest. So if an attacker steals the encrypted hard drive, they cannot read the data. So the theft happened, but the impact or data exposed is near zero because the data is unreadable for them. So there is common misconception to fix. Like many people say, encryption prevents a breach. It doesn't. Encryption reduces the impact of the breach. The attacker can steal the encrypted data, they just cannot use it. So these are different things, and distinction matters for the audit works itself. So now, why rating skills matter? A risk register with inconsistent rating is useless if one auditor rates likelihood 4 because it feels risky and another rates 2 because it has never happened here. So the two findings cannot be compared. Before any assessment, the scale must be defined and agreed with the client. So now the 5 point likelihood scale, you can see here 1, 2, 3, and 4, 5. So we have 5 levels here, or skills here, or points here. So fifth one is almost certain, which means this is happening or will happen very soon. And think of a company with no firewall and internet facing server with a known unpatched vulnerability. And someone is almost certainly already attempting to exploit it. Now, fourth one, likely, which is probably happens in most companies of this type because you have to think of excessive user permissions when there is no access review process. Very common when teams are small and busy. The third one is possible and it could happen. You can think of it ransomware attack on a well patched and MFA enabled organization, possible but not probable. Now, the second one is unlikely, not impossible, but rare. You can think of sophisticated nation state attack on a small food manufacturer. Now, the last one or first one, rare, might only occur in exceptional circumstances, almost never in practice. Now, if I'm looking at 5 point impact scale, starting with 5, which is critical, which means it is business threatening. It could cause a company to fail, face regulatory shutdown, or suffer losses they cannot recover from. Patient data breach at a hospital, or car data breach at a payment processors. 4 is a major, which is severe but survivable. Significant financial loss, delayed financial statements, or regulatory fine, loss of major clients. Now, the third one is moderate, disruptive, but manageable. And it's a partial system outage, limited data exposure, noticeable but recoverable. Second one is minor, which is small financial loss, quickly fixed, and limited business impact. And the one is negligible, barely noticeable, like a helpdesk ticket, a brief delay. So the heat map shows how two rating combines. So if you notice a likelihood 5 and impact is 1. Risk is different from likelihood, impact 5 risk. So frequent but trivial events like L5 or I1. So are managed to process. Now the rare but catastrophic events are L1 and I5, which are managed through heavy investment in prevention and recovery. Both can be high.